So my name is Dr. Craig Poku. I am a climate and atmospheric scientist based at the University of Leeds, and I'm absolutely thrilled to be here. I'm also really terrified at the same time, mostly for the simple fact that it only feels like yesterday that I was in secondary school, and let's just say that that was a while back. But again, I'm really thrilled that you've invited me to come here and talk some science with you. So yeah.
Hi Craig, what is your most favourite part of your job?
Hello. My most favourite part of my job is probably doing events like this. So as an example for me, so a little bit about my work, I focus on understanding clouds, as in the big fluffy things in the sky, better. And the reason why they're important is because not only can they be useful for weather predictions, but in particular, they're also really useful for us to understand climate change going forward. But I enjoy the science, and I enjoy doing, like, you know, the really nitty gritty maths and the really nitty gritty science. But I prefer talking about it with different groups, especially like in events like this. So I really enjoy communicating my science. That's the most favorite bit of my job. There's some people who don't like talking. I'm a talker, so that was quite natural that was about to happen, I guess.
And Greg, maybe you can tell us your favorite thing about clouds.
Oh. My favorite thing about clouds. My favorite thing about clouds is the fact that no same cloud has the same property. So the way how a cloud forms is through a process that's known as convection. And convection is simply the movement of air moving up and down in the atmosphere. So the best way you can imagine this is that if I, for example, have a layer of ground and I heat that ground up, then what you're doing is you are warming that air above that ground, and then that air will then rise, because hot air rises, cold air sinks. You will then find that that hot air will then rise so much that it will then form clouds. But because our atmosphere is so complicated, every cloud that you see up in the sky will basically have a completely different way of forming. And I find that absolutely fascinating, because it then means if you go, oh, that's fine, I can do the modeling of, say, one cloud, actually you'll find that another cloud will do something completely different. I find that really cool. For some people, they find that really dull, but I find it's really cool because if you understand how each one of these clouds form, then you can then predict what a future cloud's going to do following from that. The moral of the story, clouds are really cool, mostly because they also look really pretty, and they make really pretty photos as well.
Hi, Craig. Did anybody disregard your data, like your discoveries?
With regard, so in terms of my data, the person who tends to disregard it a lot is usually myself. So the reason as to why that's the case is that I am what's known as a numerical modeler. So I basically use computers to simulate what the atmosphere is doing at any given time. But because I am also very tired a lot of the time, I usually make like small mistakes. And the thing with numerical modeling is that you can do a lot of like simulations, and you can basically disregard a lot of the data that you have as outputs. In terms of what other people have done, yes, they have disregarded my data, but the reason as to why that's the case is because if I am modeling one cloud and you're modeling another cloud, our viewpoints are exactly the same, but they're coming from very different angles. And so what you may find is that you may disregard my data because it actually weakens your theory, but whereas it strengthens my theory. But that happens very rarely. The person who tends to disregard their data the most is usually myself. But that's because I know that it's the case that I want a particular simulation, or I want a particular way how the atmosphere is going to look. And if it does something really weird, where, for example, one crazy idea is that I actually had gravity backwards. So rather than gravity going down, gravity was going up, and I basically had an exploding atmosphere in my PC. That's not good data or good science. So I had to get rid of that. And I use that as an example of what not to do sometimes.
Hi, Craig. What inspired you to get into your job?
Hello. What inspired me to get into my job is the fact that I enjoy maths, I enjoyed science, and I also enjoy geography. So For me, so a bit about my background. I grew up in London, and I had many opportunities to do country walks and go into the countryside and really just kind of explore nature. And what I definitely found was that I was always interested in how the maths related to the science and related to the geography. So then as I went further through my secondary school studies, and then when I then went into university, I definitely found that I gravitated towards atmospheric sciences, meteorology, understanding the weather better. And then when it came to then looking at doing PhD and research opportunities, I then gravitated towards understanding like weather problems. So that's how I got into my job. And now where my job has led me to do is that I now look at how we can understand fog forecasting, and in particular, fog forecasting over northern India. So the work that I do varies. So there's some people who look at weather in, say, the UK, other people who look at it in different parts of Africa. I just happen to look at it in India now. But I find my job really interesting because there's so much you can do.
I think that's so interesting, Craig, that you work on data in India. Why is India your kind of particular focus, and is there something interesting about the fog there?
So the reason I do my work in India is because of the environmental buildup. So in order for you to have fog, you need to have pollution. So things that come out of cars, or like salt particles that come off the sea. These are all what are known as pollutants, and for fog, you need to have those pollutants. Now in the UK, we do have pollutants, so therefore we don't have fog. But in India, the level of pollutants or pollution is so high that actually it does a completely different physical setup. And the best way to kind of think about it is that for fog, you need to have what's known as saturation. So imagine you've got a sponge, and you know when you have a sponge, you put it under a tap, and it basically reaches a point where there's no more water that can go into the sponge. That's saturation. In India, you can have fog without the saturation bit happening. So that's the reason why I find it interesting. But again, if you want me to explain that again, feel free to ask me the question again. So, because I'm also fully aware that it's a very complicated problem, because a lot of people have been studying it for years and nobody seems to know the answer.
I guess that's why your job's so important then.
Yeah, so my job is important because there's so many physical processes that go into weather forecasting that it makes it a very chaotic system to try and predict. So as an example, if you want to work out whether it's going to rain tomorrow, you have to work out what the winds are going to do, what your temperature is going to be, what your moisture is going to be. You want all of these things to happen at the same time. And you find that because they're all happening at the same time, computers can find it very difficult to kind of capture and model that. And so as us as scientists, we are trying to work out how we can simplify some of those equations to then make it easier to then predict. But that's why the type of work that I do is really important. And this is why we need more people in meteorology and climate, because we need to have a wide range of opinions and diversity within the field, I guess.
Hi Craig, what are places if you have to travel for your work?
In terms of places that I travel for my work, they vary. So when I did my first research project, most of the travel that I did were to fields down south. So they were like collecting atmospheric measurements of fog. But I also had the opportunity to go up to Arran, which is actually probably quite close to a lot of you actually. That was really cool because I got to climb up Goat Fell and collect more atmospheric measurements in order for me to try and prove some of my theories. But also I get the opportunity to travel internationally. So I've gone to Canada, where I've been able to present some of my work in international conferences. This year I went to India to again present some of my work, whilst also working with some of the Indian scientists who are also looking at fog over where they are. And I also get other opportunities to go to places such as San Francisco and basically stateside. But obviously with the fact that we're in a bit of a global pandemic, it's a bit difficult for me to travel. So I'm actually doing this talk from the comfort of my own house in Leeds.
Did you ever think you would become a STEM VIP?
Did I ever think I'd become a STEM VIP? The answer is no, I guess. I've always loved science. I've always loved communicating my science, and I've always loved engaging different people in the science that I do. So when I got this email from Jamie with regards to becoming a STEM VIP, I was actually quite humbled, because somehow the work that I'm doing is getting out to different groups and different organizations, like your school, for example. I really enjoy being a STEM VIP because it allows me to basically engage my science, actually talk to different groups. And in addition to that as well, I get to do something that makes me feel very happy, which is communicating my science. So the answer was I didn't think I'd ever become one, but I have now somehow become one. So yeah, but again, thank you.
What message would you give to young people who maybe are sitting in that very classroom or across the UK thinking, nah, STEM isn't for me because I'm not good enough or whatever? What message would you give those folks?
The message that I would give for anybody who wants to consider STEM is it doesn't matter your background, it doesn't matter your race, your gender, how you identify, it doesn't matter how you are as a person. If you are interested in science, my biggest recommendation is to go for it. The thing that STEM needs is diversity, because the one thing I've definitely found being in STEM is that because I am Black British, and in addition to that as well, I also come from a working class background, I definitely found that I was approaching science in a completely different way to some of my colleagues. And that was really important because, for example, the work that I do, I have an interest in, say, air quality and pollution. And that's something that really mattered to me because as a Londoner, we were in that period where they were looking at, for example, introducing the congestion zone and figuring out ways of how they can have much cleaner air. But I definitely found that because I came into science with that perspective, that was a perspective that not many people thought about before. And now I really advocate for so many different people to come into STEM because that's what we need. We need that diversity and we need that drive. And if any one of you here are thinking STEM isn't for me, I can definitely tell you that STEM is for you. And never, ever, ever feel discouraged that it's not for you, because it is.
Do you do anything to help climate change?
Oh, wow, that's a very big question. What do I do to help climate change? So in terms of what I do personally to help climate change, I really try to focus on understanding the really complicated science and maths, and figuring out these really difficult problems in terms of like really difficult equations to then actually feed back into the numerical models that then predict future climate and future weather. So that's the thing that I definitely do. But the one thing I've really focused on for the last maybe few months is actually doing talks like this, because I definitely found that climate is something that's going to impact everyone. It's going to impact everyone here. And I think that in order for us to be able to get everybody on board with the fact that climate change is happening, we need to ensure that we have as many diverse opinions as possible in the conversation. As it currently stands, the people who are delivering climate change communications and climate change information tend to only make a very small proportion of the population. And we really need to widen that out. So I think that in terms of what I help to do in terms of climate change, whilst yes, I do focus on the science and I really focus on understanding those really difficult problems, I think that talking to people and getting people on board is just as important, because everyone here has the potential to be the next climate change leading scientist. And I don't ever want you to ever feel that you're never going to do that because I don't see me as one of the scientists. Never let that put you off. So that's what I do to help with climate change. It's actually getting people involved.
Hi Craig, what can our class as young STEM leaders do to help promote STEM in the school and in the local community?
Hi Bashira. So in terms of what you can do to help promote STEM is just talk about it. And that's something that I would say to everybody here. I'm a massive science nerd, and I definitely found that when I was back at school, the thing that definitely got my friends into STEM was me just talking about it. So it doesn't matter how big or how small a discovery is, talking about it and showing that you're excited about it will actually get people to be more excited about these things. So much so that what I've definitely found is that because I go on about how cool clouds are, I now know more people who are thinking, ooh, cloud physics is a topic I now can look into study. So show that enthusiasm, show that excitement. If there's something that you've learned at school that you go, oh my gosh, that's really cool, talk about it with your friends, talk about it with your family. By talking about these things, it not only allows you to actually feel confident in your own science, but it actually demonstrates to everybody else that science is for everybody. And if it's something that you really want to consider or you're really passionate about, then people will build onto that passion and actually go, yeah, this is definitely for me.
Perhaps some of you young STEM leaders can make your activities, events, or interactions about looking at the clouds around you.
Yeah, so in terms of looking around the clouds around you, there's an organization called the Cloud Appreciation Society, where their main focus is to get people to talk about clouds. And the one thing I've definitely found about it was when I was younger is that I would be the type of person to lie on the field and work out what funny shapes the clouds were making. So my favorite one still has to be one that looked like Shaun the Sheep, which actually is funny enough the reason why I've got a Shaun the Sheep plushie at the same time. And that's something that I would do. It's just like the world is fascinating and there's so much that's happening out there, and if there's anything in science or if there's anything out there that captures your imagination, just let your imagination go wild. A lot of people think that with science you have to be focused on, oh, I need to do all the equations, I need to do all of the really nitty-gritty science. But for me, I definitely find that science is an art, and actually you have to be really creative. And so for people who go, oh, I'm creative, but I'm not a scientist, you're probably a scientist, because you need to have creativity to be a good scientist. That's the one thing I've definitely figured out.
I'm going to ask you a question that every 3-year-old child asks. Why do clouds look like elephants?
The reason why...
Sorry, this one is not on the list.
It's not on the list, but it's an interesting question. I would say that the reason why clouds can look like elephants is because of the very, very fine physics that's happening around the cloud. So you may notice that clouds can be quite bumpy. And the reason why they're quite bumpy is because there's a process that's known as entrainment. And entrainment is very simply the movement of air going from A to B. So the best way to imagine it is that if I put a stick in a river, and as that river goes down and you see that the stick just goes wow, 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 and then carries on down, that turning motion is what's happening at the side of the cloud. So because you've got entrainment happening, or these kind of swirling motions happening at different scales around the cloud, some of them will form elephants and others will not. If you can show me a photo of a cloud that forms an elephant, please send it to me, because this will make it an excellent example of cloud physics in my honest opinion.